So here we have my Sigma prime lens that I'm just testing out for the time being, as we'll probably end up exchanging it for a different lens at some point. But I just want to illustrate something on this lens, which is at the moment I'm testing out. At the moment we're testing out the focus capability of this lens in terms of extreme apertures and depth of field. So in this video I'm going to illustrate depth of field. So I just want to show you guys the differences between apertures of f4.5 to f16, as well as the minuteness of using an extreme telephoto lens like this on the subject field that we have over here. So let's have a look. What we have over here is we have a light box, we have an Android figurine, a Deredex starship from Star Trek, and an Everbuild PVA bond glue bottle. So we're going to have a look at how our depth of field relates. And you'll get to see the differences between f4.5, f5.6, f8 and f16 in some images I've got that I'll show you shortly. But in this video I just want to illustrate depth of field so you can have a look for yourself. How does it affect subjects? So let's have a look. So in this video I want to demonstrate depth of field. Now we can exaggerate depth of field using an extreme telephoto lens. So this is a wildlife stroke sports photography lens. It's a prime 500mm Sigma 500mm f4.5 APO EXDG HSM lens. These lenses are typically used for taking imagery of wildlife and sports from long distances. It has the effect of blowing out your background extreme to an extreme point. So I wanted to demonstrate how moving the focus ring on this lens by a very slight amount, unlike other lenses you may have experienced, such as say a 70 to 200, a 50mm, you won't get this sort of extreme depth of field because of the the compression of the telephoto lens. So I'm just going to demonstrate how changing the focal range, the focus ring, slightly affects your depth of field. So looking at the actual three models we've set up here, they're about 10 centimeters apart. So if we just move the focus ring, I just want to demonstrate this so you can see in the actual video. So the starship is in focus. As you can see, the character in front of it has gone blurry. That's because the focus range has moved. And the thing with telephoto lenses is the focal range is so small. You know, you can get literally an eye in focus and get feathers out of focus on the same subject, because the focal range is so tiny, so minute. You have to be spot on with your focus. So let's keep going. And there we've got the starship out of focus now, and now the bottle, the Everbuild PVA bond glue bottle, is in focus. So if we come back a tiny bit, just a millimeter or so, we're bringing the starship into focus, and then a bit more, and then that's gone out of focus, and you can clearly see how the bottle has gone completely out of focus, and obviously you can see the Android character is in focus. So this is the difference between depth of field, how racking the focus on your lens, your prime lens, your zoom lens, whatever lens you've got, can achieve different results. And I hope this was useful to you. So in this video I want to demonstrate bokeh. So what is bokeh? Generally it means highlights in the background, how lights appear. And the easiest way of doing this is using Christmas lights behind a bottle that we've set up. So what we're looking for is those lights, that bokeh, we want to appear to be round circles. We don't want misshaped onion rings, anything like that. So we're trying to get a good visual representation of what the lights look like out of focus, so it looks reasonably good. So I'm going to demonstrate in this bottle here so you can have a look for yourself. So let's just bring that bottle into focus. Obviously you can see we've got 2 Christmas lights in the background on a Christmas tree. So let's just rack our focus a little bit so that we've got the bottle in focus. There we go, we've got it in focus there. Now what I can tell you is the round light circles are beginning to take on the shape of a misshapen onion ring to the edges. However, in the centre of the actual picture near the bottle, we can see we've got a uniformed circle, which is pleasing to the eye. So, obviously at the edges of the frame on this particular Sigma lens, it's not fantastic, but you probably wouldn't notice it. But closer in to the centre, we can see, while it is tending to be a bit more of an onion ring look, it's still reasonably good and pleasing, as you can see in this imagery. And I can tell you on the bottle, it's quite sharp and very pleasing to the eye. Okay, so let's have a look at some of the images we've got. So at f4.5, you can see it's blowing out the background quite a lot. Let's have a look at the next image at f5.6. It's not as much blown out as the f4.5, but it still blows out the background significantly. Let's move to f8. f8 is typically pretty good for getting a lot in focus in general. However, when using an extreme telephoto lens like this, even f8 doesn't get a lot in focus. So let's move on to f16. Looking at f16, we've got quite a bit in focus here. You can still see the bottles out of focus quite a lot. So obviously we will need to go even further in terms of depth of field for a better image. So let's have a look at f32. So in f32 you can clearly see that more is in focus, but what tends to happen is when we use bigger or smaller depth of fields, going up the numbers from f16, f22, f32, we start to introduce diffraction. What is diffraction? Well, it tends to be artifacts in the image that gives us a softer image, and typically speaking, I'm trying to avoid going above f16 whenever possible. Anyway, I hope this video helps you out and it was interesting to look at, and thanks for watching.